Okay, right now we're looking at position and change of position. And we're going to look at that with graphs, data tables, motion diagrams, and pictures. All right, this first one we're looking at a position time graph, an XT graph as we know it as. And you guys have graphed these in the Bubble Tube Lab, and we've been looking at them over the last couple of class periods. We know that XI, we've already established that XI is our starting position. So let's look at our graph. To find our starting position, I'm going to go to 0 seconds, or whatever my time unit is. Happens to be seconds now. And at 0 seconds, I'm looking at where my position line is. In this case, at 0 seconds, my object is at the 0 meter mark. So I'm going to go ahead and write that in. My starting position is at 0 meters. I'm following my slope along to see where it stops. It stops right there. And I want to know what the position is when it stops, my final position. If I follow that along over there, I can see that that object stops at 70 meters. So my final position, XF, is going to be 70 meters. Now when we're doing change of position is denoted like this. The triangle shows you change. Anytime you see a triangle in physics, it'll mean change. And with the formula is XF, final position, minus XI, initial position. And you have to do it in that order, or else you will come up with the wrong change of position. All right, in this case, we've got our final position is 70 meters. Our initial position is 0 meters. So we come up with a total change of position of 70 meters. Remember, we always put our units on in physics. So we've got a total change of position of 70 meters. This is a positive number. We don't always write the positive, but it's inferred. We've got a positive number, but we can see from our graph and our slope that our slope is going in a positive direction. So what direction did this object go? It went in a positive direction. Okay, now we're looking at change of position from a data table. And this data table isn't any different than what you guys created when you were doing the Bubble Lab. You had your position and your time. So we're going to our starting time, 0, in this case it's seconds, so 0 seconds, to find out where our starting position is. In this case, this object is starting at 10 meters, not at 0, like often we see, but it's starting at 10 meter mark. That's its position. Our final position, let's go down here and see what we have data for, is at 42 meters. Again, when we're doing change of position, we know that change of position is X final minus X initial. And in this case, my final position is 42 meters minus 10 meters. So I'm going to have a total of 32 meters for my change of position. Now, this is a positive number, but we can see it starts at 10 meters and the numbers get bigger. So we know also that this object went in a positive direction. Okay. Moving on, let's look at starting position and change of position with a motion diagram. So here we have a motion diagram, and excuse me, I forgot my units on this one, so we're going to make it meters. Starting position is where my starting dot is, and you can see that at 0 meters is my initial dot, showing where it's starting. So my starting position in this case is at 0 meters. My final position where the last time unit is at 20 meters. So my XF as my final position is 20 meters. Now in this case, we know that change of X, our change of position, is equal to XF, 20 meters, minus XI, 0 meters, for a total of change of position of 20 meters. What direction did it go? Well, you can see from our velocity arrows that we're pointing to the right. And we've established in this class that to the right is a positive direction. So in this case, again, our object is traveling in a positive direction. Okay, so this is the first time that we've looked at pictures, and you're going to find a real consistency here. Anytime you see a light colored car, like the one on your left, that's going to be the car at your initial position. Anytime you see a dark colored car, it's going to be the one that's at its final position. Now, the big key about using pictures to determine change of position is that you have to be consistent. So I like to always use the front of the car. See the front of the car right here to establish where it's sitting at its initial position. So in this case, you can see that my initial position from the front of the car, starting position is going to be -10 meters. Now it makes sense if I come here and look at my final position, if I were to use, say, the back tire as my marker for where that car was, you can see how that would throw off my measurement. I need to be consistent with whatever I use my measurement with. I'm going to use the front of the car. So from the front of the car, you can see that the final position is at 5 meters. Now this is an important case of why it's always important to put xf minus xi and not flip those. Because when you do change of x, in this case, equals xf minus xi, let's look and see what we got. We have change of x in this situation is equal to 5 meters minus a -10 meters. Now we know from our math class that anytime you have a negative minus a negative, excuse me, let me say that again. Anytime you have a minus a negative, that turns it into a positive number. So when I go change of x is 5 plus 10 meters. So my total change of position in this case is 15 meters. What direction did this car go? This car went in a positive direction. You can see that from our pictures. Let's try one more. Right, again, we said in this case that every time we see these cars, the light colored one is going to be our starting position. So our light colored one is going to be our starting position. Our dark colored one is going to be our final position. Right? I'm always going to measure my car from the front bumper. So in this case, my starting position is going to be 10 meters. My final position is going to be -5 meters. When I do change of position is equal to xf minus xi, let's see what I got. I've got a change of position. My final position is -5. My initial position is 10 meters. So my total change of position is -15 meters. What direction did this car go? This object? This object went in a negative direction.